Before starting anything else, let's do a let's rewrite this code. Uh, let's just do it. All right. So the basics for this code. Let's jot them down. The first one would be sort in order of finishing time, I would say, and then the other one would be when you have sorted them into the order of finishing time, then what you would be doing is that you would reverse the graph, and then you would once the graph is reversed, and then you could be able to I would say, is the sound working fine? Yeah, it is. So the moment you have reversed the graph, then you will be performing DFS on the reversed graph. That's it. So let's start by creating functions. First function would be DFS on the reverse graph. When you have to perform DFS on the reverse graph, what you are gonna need is the array list of adjacency, but if the graph is reversed, then it would be a transpose one that we are gonna create. I guess that's all you need. I mean, yeah, you would need a boolean visited array so that you could be able to find out that alright, I had already visited this guy, so no need to visit it again. And then after this, I guess you would just need what else? Yeah. What else you would be needing? You would be needing an array list, and then the boolean. I guess that's it. Yeah, that's it. What's gonna happen is that while we're gonna perform the DFS, but the thing is, like, how are we gonna perform DFS? That is the thing. When we say that we are gonna perform DFS on the reversed array, the reversed graph, that means, yeah, I mean, the first step is sort in them order of finishing time. This is basically stack. This is stack. You're gonna use stack here. So I guess the thing is, for all the elements, that's gonna happen into the main function. So basic DFS analogy, I guess it's gonna get followed right here. So when we're gonna call it, we're gonna just have a node on which the DFS is being called. We're gonna be like if visited node, if like that's false, if it's not visited, then do one thing. If it's not visited, then do one thing. Mark it as visited because it's gonna get a DFS, and then call DFS on it, wherein wait. uh, we are gonna be like for int I or the neighbors out of transpose dot get node Alright, so we can be like of the node you get the neighbors, and then I guess this whole if thing, I don't like it there. For some reason I don't. All we have to do is we have to be like, take out the neighbors of the node and then check that if the visited of neighbor, if it's like false, then you call the DFS on it, that is the neighbor transpose, and that is the visited array, and that's it. Nothing else. Yeah. For int neighbor, we get the nodes, we get the neighbors of the node, we check if they are visited. If they're not visited, we put a DFS on it. Yeah, but we'll have to mark them as visited as well. So visited of that neighbor is gonna be true, and then we call the DFS. I guess this is enough for the DFS. Let's do one thing. Let's what did we have to do? What else in the order of finishing time? Yeah, so in the main function we can have a stack integer stack new stack, and now we can have a function finish time that would take in we can have a function finish time that would take in obviously a stack, I would say. Yeah, a stack. It would take in the elements of the array list, the adjacency list, right? And then it would take in the elements of the adjacency list, and then what else? We are storing the elements into a stack. We have the adjacency list, out of which we are going to take out the elements. I guess this thing is also going to be used. Let's do one thing. Let's create this into the main function as well. Let's have int v equals yeah. Okay. We have the visited. We have the visited one. What else? Analyst. What else can we take? That is the thing. Like, what else should we take? When we have to sort it for like for the finishing time, I don't think so we have to take a particular node. So let's not worry about that then, right? Yeah. So the finish time would be like, all right, so I'm gonna perform a DFS and I'll keep performing the DFS, and when one element like ends where it can't go any further, I would be like, all right, that is your thing. Now you can just like, you know, like you have like ended, so you just are gonna get added to the stack. So I'll keep adding the elements to the stack, right? Cool. So I guess it's gonna start in like for int. I guess I'll have to take a node. Yeah, I guess I'll have to take a node. Yup. Else what I'm gonna take care of, and dot get node. I'm gonna be like if it's not visited, if visited node no, the I. If it's like not visited, then I'm gonna be like, cool, let's have it DFS on you. Yeah. Wait a second. This is the thing. Yeah, I guess I have a DFS function, so let's not call it this. The function works well. I can just be like I can be like, and then I can be like visited, and I guess that's that. I guess that's that. And then when I have covered all the neighbors, I covered I, yeah, and then can I, like for example for 0, I'll cover 2 not visited. For 2 I'll cover 1, and for this I'll cover 0 if is 0 visited. Yeah, it is. So if 0 is visited, then we would get out, and then we would be like, all right, 1. What else do you have? Because this 0 was visited, so we out of the loop. Here the node is still 1. Here it was 0. Here it's 1 0 already visited. So don't we have to mark it as true as well, like visited what is happening, like visited I equals true, as if like I'm visiting it, right? I mean, I guess we should. Yeah, and then I'm gonna be like I know that there is this thing stack dot push gonna come. I know that. Yeah, I completely understand that. I'm just trying to figure out, like, if the call starts for 0, for example, it's 0, it could go 2 or it could go to 3, so it's 2 not visited. Cool, make it as true. Should we make it as true? I don't know. I don't think so, because if we make 2 as true, then we do it for 2, then we are like, all right, here it's 2, here it's gonna be 1. I'll make this as true, I'll do it for this. Here it's not gonna be 1, it's gonna be 0. Is it true? Like, is it like false? No, it's not false, it was marked true. Yeah. Alright, so I can just take this statement, because I never explicitly marked 0 as true, and I can be like, hey, right here, right, I can be like, alright, hey node, you have been marked as true. And now the thing is, the moment like I is like 1, here it's like 0, here it's like 1, it's gonna point towards 0, it's gonna be like, alright, it was true, I'm gonna come out of it. I'm out of the if, and I'm gonna be out of the for because there is no other neighbor than 0 for 1. I'm gonna push 1 into the stack. Yeah, 1 was finished. Then I'll come back. I'll come back to 2. Yeah, and then I'll be like, alright, what else do we have here? I guess the 1 I was marked true, so hey, I'm done. No other neighbor, so I'm gonna come out of the if, I'm gonna come out of the for, I'm gonna get pushed. So 2 is now in. 1, 2. Now it's gonna go to the 0, and it's gonna be like, alright, your call for this particular DFS call, considering here we have 0 and here we have 2, is done. This DFS call is done. But hey, wait a minute. For I now I have 3. So yeah, is it true? No, it's not true. Then have a DFS for it. We mark 3 as true. We're gonna be like, hey 3, do you have any neighbors? Right, I have neighbor 4. I is gonna be 4, this is gonna be 3, and then I'm gonna be like, oh, let's do one thing, let's mark it as, let's mark 4, let's see if it's visited. No, it's not visited, you know, let's do a DFS, let's do a DFS for it, you know, let's mark it true, and then we're gonna be like, alright then, hey listen, I don't have any neighbors, so no for loop for me, I'm gonna get pushed. 4 gets pushed, and then 3 is like, alright man, this DFS call is, I had no other neighbors. 3 gets pushed, and then it's gonna be like, hey 0, I don't have any other neighbors. Now 0 is gonna be like, I don't have any neighbors, so it gets pushed. Alright, so it works. Cool. So this is the complete DFS thing, if you know what I mean. Yeah. Yep. Node is gonna get used. I never used stack. Okay. Stack, that's it. Cool. Works. So then I have the Bluetooth connection. Easy. Cool. I don't know why Bluetooth sucks in Windows. It's fixed. So yeah, now what else has to be done? Let's create a reversed adjacency list. Alright, how do we do that? The question, because we have to like reverse the graph, so we'll have to create a reversed adjacency list as well. So we can be like for, let's create transpose. I feel like this is like very lengthy, like very lengthy, but it's like a, you know, algorithm, so I guess it's fine. But trans so you take out the neighbor, you add the node to it. Yeah. Alright, so we have our uh, reversed graph. Now all we have to do is DFS and that's it. We have a DFS function that's performing a DFS on the DFS basic DFS function, and then I guess for this also it has to put out, I feel like it's better placed here. What else? I guess we can have like int count set as 0. We can be like, alright, do one thing, while stack dot is empty. While stack is not empty, wait. I have to manipulate the stack first. Should I just call the function and that's it? Like, should I just call the function in terms of like finish time, providing it with wait, I guess another for loop would help. Now let's try to analyze like why this for loop would be helping, because it's gonna be like, alright, hey, do it for 0, hey, 0 2 3, cool, do it for 1, do it for this, do it for that, do it for that, cool. For I guess the same thing, control C, let's take that. It's like gonna be for the adjacent. We're gonna remove this line because we're not trying to create something. We're gonna be like, apply finish time wherein that is the question. How do I apply that? That is the question. Alright, it was just a singular for loop. No, this is like for the fill order thing. Okay, but yeah, I guess that's what we did. Fine, no worries. DFS on the reverse graph, I guess we did this thing as well the right way. End way, stack, boolean, blah blah blah, fill stack by finishing time. Yeah, this is the thing. Alright, so singular for loop, if not visited, cool, understood. Singular for loop, if not visited, then if you're not visited, then finish time, providing it with, what does it require? Node, that is I, providing it with stack, providing it with array list, providing it with boolean visited. Alright. Cool. So problem solved. So while the stack is not empty, do one thing. If not if int node equals stack dot pop, and then we're gonna be like if visited node, because that's what we care about. Yeah, we just removed, like for example, we removed one element from the stack, and then we're gonna be like, what else? What to do with this element? I mean, like we can be like 0 to 1. This is like one component. Yeah. If it's like, if like this is one component, then we can be like, I guess these are individual components. We have 3 components, 1, 2, and 3. So we can be like, let's, if that node is like not visited, then first visit node true. If that node is not visited, yeah, if that node is not visited, then what are we gonna do? We're gonna be like you know, put a DFS on it. Put a DFS on it, and then DFS is gonna take care of the neighbors and everything. What does DFS require? Change the name. DFS is gonna be like, provide me the node. Cool. Oops, my bad. Node, you have it. You have it. Visit, have it. Yeah. And the moment I have to hit DFS, I'm gonna be like, hey, DFS, you over? Let's increase the count. Yeah. Yeah, because the moment a DFS gets hit is the moment I have encountered one strongly connected component. That's that. So we can just be like return count. Y int arrow list. Finish time. Wait, what? Method DFS in class solution can be applied to the given types. DFS. Where? I don't like this thing. Where it's happening. Oops. Oh, the line was right. 57. Huh. I always thought geeks for geeks is bad at that. My bad. Alright, wrong answer. Output 0. Alright, transpose loop is wrong, let's not read into that. Second DFS uses wrong graph. Alright. Visited check logic. Wrong recursive call. What else? What else? 4 issues. So first of all, let's talk about the transpose. Why is that wrong? And I less than V. Oh, arbitrating over transpose. Wait. Wait. Alright, understood. I should have used the adjacency one right here. As in adjacent dot get I. Adjacent dot get I. Cool. Okay. Second DFS uses wrong graph. Node adjacent. What else? I was thinking of this, like, is this right or not? I guess I don't have to care about it. This thing is like already gonna get taken care of in DFS, right? What else? Wrong recursive call in finish time. Like, finish time. So let's see inside finish time. I mean, I get it, but alright, so about hint 4. The question is that, for example, I get it when you say like wrong recursive call because I'm calling DFS, but I should be calling finish time. The thing is, in the main function, my main understanding with the finish time function is basically to sort the nodes in the order of the finish time. So the moment they get finished, the moment they can't go anywhere else, I add them to the stack. So my question is that, does it matter I call finish time or I call DFS? Because the thing is, both are doing the same thing. The finish time is only doing one thing extra, and that is adding it to the stack. That is like after the for loop, outside of it, and the stack that has been created is gonna get created into the main function. So it's not getting created into the initial finish time function. So that's what I'm saying. Like, if my stack is getting manipulated as per the calls, then why is it a problem to call the identical or same method? It's like, you know, Oh, okay. Okay, understood. Understood. DFS is having no template to push into the stack. My bad, my bad. Shouldn't even have questioned it. So sorry, so sorry. Finish time. What does it require? Oh, it requires a stack. Hmm? Wrong answer, wrong answer. Wrong answer. Okay. Visited array reuse. I understood. It's like uh, should I um I don't think that's necessary for every stack pop creating a new visited array. Should I? Every stack pop new array. Oh, okay. Understood. You just want me to be like, hey, start from all false. Yep. Wow. Very nice. Very, very nice. Will it show me that test case? Stupidity, I would say. I mean, it makes no sense to put a solution like that. But anyways, who cares? That's the thing. Let's open graphs, other algos, bridges. Let's start with the bridges now. Bridges, bridges, bridges. So I'll stream again. Uh, the thing is, I'll go have lunch and then I'll stream again. So yeah, I'm gonna close this for the moment and then I'll be back. So yeah, don't worry.